Hello and welcome to a new chapter called Data Structures. It is one of the most important chapters of computer science. So this is the part 1 of this particular chapter. So today we are going to discuss about introduction to data structures. We will just have an overview of the entire data structure unit in brief. So let's try to understand what a data structure is. A data structure refers to a particular way of storing and organizing data in a computer so that it can be used more efficiently to give optimal performance. So in this particular chapter, our aim will not just be to code a program, it will be to code a program in the most optimal or efficient manner. The significance of data structures lies in the fact that they help a computer perform tasks in more efficient and productive manner. So uses of data structures helps in making our programs more productive so that it can run faster and so that it can be more efficient. So let's try to understand it with the help of an example. So what is this? This is just a water bottle. Okay, what is the purpose of this water bottle? The purpose of this water bottle is to store what? The purpose of this water bottle is to store liquids. So can we store some biscuits and all? Yes, we can store it by breaking and doing certain modifications, but that will not be the most efficient way of storing the biscuits. Similarly, this is a container. This can be used for storing biscuits and various type of namkeens and all this type of things. But can we store liquid here? Yes, we can store liquid here. Can it be used as a water bottle? Yes, it can be used, but will it be the most efficient way if we use this particular container as a water bottle? No, it will not be the most efficient way. So basically the work of data structure is also somewhat similar. So even if we can do a particular program with the help of different type of data structures, then also what we will do, our work will be to choose the most efficient one out of all the data structures. What is the need for data structures? Data structures are important way of organizing data in a computer. So with the help of data structures, data are organized in a more sequential and organized manner. It has a different way of storing and organizing data so that it can be used efficiently. Efficient use of data happens with the help of data structures. It helps us to understand relationship of one data element with another. So there may be various data elements and the relationship among those data elements can be easily established with the help of data structures. It helps to store data in a logical order. So in a logical or in a sequential order, data can be stored with the help of data structures. It stores data that may grow and shrink dynamically over a period of time and allows efficient access. So there are certain situations where our data may grow and shrink with time. Like from insertion, what will happen? The data size of data will increase. From deletion, what will happen? The size of data will decrease. So dynamically insertion and deletion, that means grow or shrink, can happen with the help of data structures. So let's go to the classification of data structures. So we can classify it into primitive data structures or non-primitive data structures. What are primitive data structures? Primitive data structures consist of the basic data types, which are int, float and strings. And non-primitive data structures, they are basically made using primitive data structures. They can be classified into two types. One is linear, other is non-linear. If elements are stored in a sequence, then it is called linear data structures. If they are not stored in a sequence, then it is said to be non-linear data structures. Examples of linear data structures are arrays or linear list, stacks, queues and linked list. Examples of non-linear data structures are tree and graphs. Let's try to discuss them in a little bit details. So what are primitive data structures? The primitive data structures are the basic data types that are available in most of the programming languages. Since we will be doing programming in Python, what are the basic primitive data types here? Int, float and strings. So these are called primitive data structures. The primitive data structure are used to represent single values. So in, let's say we'll consider int. If I write x equals to 5, x is storing what? X is storing a single value. It is an integer type. If I write x equals to 5.4, it is also storing a single value which is of floating point type. If I just write here x equals to, let's say, Raj, it is also storing a single value which is Raj, which is of the type string. So these primitive data structures are basically used to represent single values. Examples are integers, floats and strings. Next we come to your non-primitive data structures. The data structures that are derived from primitive data structures are known as non-primitive data structures. So using a combination of strings or combination of integers or combinations of floats, we can derive some data structures. So whatever data structures are derived from the primitive data structures are called non-primitive data structures. They are used to store a group of values, not just a single values. Okay, they will store more than one values of different data types. Examples are arrays or linear list, stacks, queues, linked list, trees, graphs. All these fall under the category of non-primitive data structures. As per our syllabus, we will be discussing linear list, stacks and queues only in details. Okay, that too in a different chapters. Here I will just give you an overview of all these different types of data structures. Now let's come to linear data structures. In linear data structures, the elements are stored in a sequential order. Okay, so remember that in case of linear data structures, we store the elements one after another. One after another means in a sequential order. The linear data structures are, first is array. What is array? Array is a collection of some data of same data type stored in consecutive memory locations, and it is referred to by a common name. So what is it? It is a collection of data of same data type. So let's say, okay, let's say we have a list x equals to 4, 5, 18, 42. Okay, here this consists of data items of the same type. What is the type? All the data elements are of integer type. Now how they can be represented in memory? They can be represented in memory as follows: 4, 5, 18, 42. Okay, each of these data elements will have an index which will start from 0. If I consider from the left hand side, 0, 1, 2 and 3. And each data element will have a ID, or it can also be referred to as address. So what is array? Array is a linear data structures which stores more than one data elements of the same type. Okay, so the name of this array is X. It is storing data items of what type? It is storing data items of integer type. So if I write y equals to 4.5, 8.6, 72.9, this can also be called as an array because it is storing data items of the same type, which is what? Which is a floating point data type. Okay. Next, if I say a equals to 4.531 ABC, what is this? This is a linear list. But can it be said as an array? No, it is not an array. Why? Because the data items are not of same type. They are of different types. I hope arrays are clear. Next, we'll go to linked list. What is linked list? A linked list is a collection of data of same data type, but the data items need not be stored in consecutive memory locations. So in case of array, what happens? The data items, they are stored in consecutive memory locations. For example, if the memory location of this is 1, then this can be, let's say, 102, this can be, let's say, 103. These are just fictional addresses, these are not real addresses, but I am just giving you an example that the addresses will be in a sequential manner. But in case of linked list, these are also a collection of data items, but here the elements may not be stored in sequential memory location. So a linked list consists of various parts and each part is known as a node. A node basically consists of, this is called as a node. It will basically be consist of two parts. First is the data part, and next is the pointer or the address part. Okay. Now the first node is known as the head or the start pointer. Okay. It will consist of the memory location of the first node. Let's say the memory location of the first node is 102, the second node is 104, next is, let's say, 106, let's say next is 108. So what will be stored at start? The address of the first node, which is 102. Now if this is linked to the next node, this is the what? This is the pointer part. So here what will be stored? It will be 104 will be stored. Now instead of 104, if 106 is stored here, then this will change, it will point to 106. Okay. And what does the first part signifies? First part signifies the data. Okay. What is the data item of this node? The data item of this node is 105. What is the address of this node? The address of this node will be the next node to which it is pointing. If it is pointing to 104, then here 104 will be stored. If it is pointing to, let's say, 106, then here 106 will be stored. So let's say this particular node, what is the data part? Data part is 2. What is the information or the pointer part? The pointer part is, since it is pointing to the next part, here what will be stored? 108 will be stored. In the last node, what will be stored at the pointer part or the address part of the last node? For the last node, in the address part, null will be stored. Null signifies the end of a linked list. Okay, we will not be studying linked list in details as per the syllabus. Next, we have stack. What is stack? A stack is a last in first out linear data structure in which insertion and deletion takes place only at one end, called the top of the stack. So what is a stack? A stack is a linear data structures where elements are stored in the form of LIFO technique. LIFO means last in first out. That means the data item which will come in the stack at the last will be removed at the first. Let's try to understand it with the help of an example. Let's say you went for a marriage party. Now when you will go for having your food, then what will happen? When the plates are stored in a sequential manner as shown in this particular figure. So this is an example of a stack. Here whichever plate was stored first will be used up last. Let's say this is you. If you have come here, will you take the bottom plate or some plate from the middle, or you will take the plate which is at the topmost part? You will take the topmost plate. That means removal or deletion happens at the top. Also, now if let's say the number of plates has decreased, so new plates needs to be inserted. Where will the new plates be inserted? At the bottom, at the middle, or at the top? At the top itself. That means both insertion and deletion happens at only one end of a stack, known as the top of the stack. Okay. It can be compared just with the stack of plates. So we can represent it somewhat like this. Okay. So at first, top will be, let's say, -1, that which signifies that the stack is empty. Let's say the capacity of this is 1, 2, 3, 4. Now let's say one data item is inserted here. Let's say 7. So when 7 will be inserted here, it will come to this particular position. So top will become top plus 1. What is top now? It is minus 1 plus 1, top will become 0. These are the indexes 0, 1, 2, 3. So 7 will be stored here. Let's say now we have inserted a new elements called, let's say 3. What is the value of top now? The value of top is 0 now. When 3 will be inserted, now the value of top will be incremented by 1. So now top equals to top plus 1, this formula will be applied. That means 0 plus 1, it will be how much? 1. That means 3 will be stored here. Now let's say we have to delete. When we delete, top will be decremented by 1. That means top will become top minus 1. So if we delete, we cannot delete 7 before deleting 3, because deletion also happens only at one end, known as the top of the stack. Now this is the top of the stack. We have to delete only 3 first before deleting 7. So at first, now 3 will be taken out. So if we take out something from the stack, it is known as pop. If we insert something into the stack, it is known as push. Many things are there related to stacks, but since this is just a introduction where I am discussing all the data structures in brief, so I'll wind up the discussion on stack at this point only. I'll be discussing stacks in much more details in the upcoming chapter, upcoming topic on stacks. When we'll be discussing stack in details, then more details regarding stack you will be able to know. Okay. So just remember this LIFO, last in first out. That means the elements inserted last will be the elements which will be removed first. Next we'll go to queue. What is queue? A queue is a first in first out linear data structure in which insertion takes place at one end called the rear and deletion takes place at one end called as the front. Remember this thing. So what is queue? It is also a data structure. What type of data structure? It is a linear data structure, but here insertions, here data items are stored by a technique called FIFO or first in first out. So what is queue? From the word only we can say that, see, when you, let's say you went for watching a movie to the theater. So while going for ticket collection, whichever customer will go at the very first will get the chance for the ticket first. Whichever customer will go at the second, that customer will get his ticket at the second position, and so on. Okay, so here first in first out, who will go first, they will receive first. Who will go second, he will receive second, and who will go last, he or she will receive the items at the end. Okay, it can be visualized as follows. As you can see, in case of stack, I have represented in this format. That means the bottom is closed here, but queue is not closed. In queue, both the ends are open. Okay, in case of queue, insertions and deletion happen at different ends. In case of stacks, insertions and deletions happen at the same end, but here insertion and deletion will happen at different ends. Insertion happens at one end called as the rear, and deletions happen at another end known as the front of the queue. Let's say we have elements 4, 5, 8, 7. At first 4 will get into the queue, then 5 will get, then 8 will get, then 7. Then while removing, 4 will have to go out first, then 5, then 8, then 7. Removal will happen from the front and insertions will happen at the from the rear end. Okay, more about queues when we'll go to that particular topic in details. Next we go to nonlinear data structures. So in case of nonlinear data structures, elements are stored based on the hierarchical relationship among the data. Here the elements are not stored in some sequence. Here there will be some relationship among the various data items, and based on that relationship the data items are stored. The first type of nonlinear data structures are the trees. What are trees? Trees are used to represent data that has some hierarchical relationship among the data elements. So in case of trees, there is some hierarchical relationship among the data elements. We will not go into deep of trees, we'll just have to know the definition. This is how a tree data structures look like. The first element is called as the root, and this bottom elements, these are known as the leaf, and these are basically called as the nodes of the tree. So this is a tree. Here we have another tree. These are known as subtrees. Okay. So discussion on trees is out of scope. As per the syllabus now, you will get this in your higher levels. Next is the graphs. What is graph? A graph is used to represent data that has relationship between pair of elements, not necessarily hierarchical in nature. So in case of trees, there is a hierarchical relationship among the data elements, but in case of graphs, it's not necessary that there should be a hierarchical relationship among the data elements. Graphs are basically used for electrical and communication networks, for airline routes, and for mobile networks. So it basically looks somewhat like this here. So these may be the nodes of a graph, and these nodes are connected to one another. Okay, these are basically known as the paths or the routes. What will be the main aim of the graph data structures? The main aim will be of the graph data structure will be to optimize such that it traverses the data item traverses the least amount of path while going from its source to destination. Okay, that's why it is used in mobile communication networks. So let's say if this is node 1, 2, 3, 4, 5. Now for going to the node 5, what there are different paths. Path may be from 1 to 2, 2 to 3, 3 to 4, then 4 to 5. This is one path. Another path may be from 1 to 2, then 2 to 5. What will be the different cost? If I go from here, let's say the cost is 1 for each path traversed. Now here if I am going, the cost is how much? The cost is 2. But if I am going through this path, the cost is how much? 1. Okay, so which path will be chosen? This particular path will be chosen. That's the main aim of the graph data structures. Okay, so here I have given you an overview of the different data structures available. Okay, from the next class I will be discussing each data structures, specifically linear list, stacks and queues in details as per the syllabus. I hope that this session was useful. Thank you very much.